Let's look at how we can use trigonometry to find an unknown side in a right-angled triangle. Now, I've got two examples here and we're going to work through both of them to show the two different types of questions that you can get with these. I've written the steps down here that we need to follow, so let's have a look at this first, and you might like to write this in your workbook. Step 1, work out if you need sine, cos or tan. Step 2, write your trig equation. And step 3, solve for the unknown side. Alright, so the easiest way to learn this is by actually doing it. Let's have a look here. We know 40 degrees is this angle here. We're interested in finding the length of this side, x, and we already know that the hypotenuse is 5. So think about what sides you have. Relative to the 40 degrees, we have the adjacent side and the hypotenuse. So think to yourself, I have A and I have H. Now come back to thinking about so, ka, toa. Remember, we've already learnt that. Do we have O and H, A and H, or O and A? Now we have A and H. That tells us we need this bit, the ka bit. And that reminds you we need to use the cosine. So away we go and we write down our trig equation using the cosine of 40 degrees. So here's how you do it. You've picked that you're using cos. So write cos, write the angle that you are finding. And then we know that the cos of a certain angle is the adjacent side, in this case x, over the hypotenuse, which is 5. Okay, how do we go about solving that? Well, to get x by itself, we just need to multiply both sides by 5, don't we? Because we know what x is when it's been divided by 5. So we want to find what it is when it hasn't been divided by 5. So if we multiply both sides by 5, then we'll have 5 lots of cos 40. I can just put the 5 out there, just like you can write 5x. You could put a dot also to show times. You could even write a times sign, but I can just smush it together, and this means 5 times cos 40. And I've multiplied both sides by 5 here. These ones, of course, cancel out. And if I write that out all nice and tidy, I've got the x on one side of the equation by itself, and on the other side I've got 5 lots of cos 40 degrees. Now, the way to do this at this point is to pick up your calculator, and it's going to do all the hard work for us. So you literally just type in 5 times, and then you hit the cos button, and it asks you for an angle. So you type in 40 degrees, just 40 will do, and close the brackets and hit equals. Literally 5 times cos 40, and it comes out with an answer. It says it's 3.83 with a variety of other things. Let's say we'll round that off to 2 decimal places because it goes on. Now at this point I look back at my picture and I say, does that seem about right? If this is 5 centimetres, would this be 3.8 or so? And yeah, that seems pretty reasonable. If you've put it in your calculator wrong, or you've made a mistake here, this number will probably come out looking really wacky. So always check it with your picture to see if it makes sense. You can also check back to the picture to see what units we're working with here and put those into your answer. And we're done. Okay, now in this example, notice that the unknown was on the top of a fraction here. So the way we got it on its own is we multiplied both sides by what was on the bottom. Now when we come to do this other example, it's going to look a little bit different. I'm going to rub this one out so I've got a bit more space. Now here, first thing to do is to check if we need sine, cos or tan. We've got 56 degrees in the corner. We're interested in this hypotenuse, and we have a side that is opposite the angle that we know. So we have opposite and hypotenuse, O and H. So think so, ka, toa. Which one is it? Sine. So next thing we do is we write our trig equation. We say sine of 56 degrees equals, it's always a certain ratio, 10 over x, because opposite over hypotenuse. Now you'll notice that this time the unknown is on the bottom. It'll either be on the top or the bottom every time. So there's only 2 sort of ways that this can turn out. Now when you're solving one like this, you can either do it in 2 steps or in 1, depending on whether you like to sort of make a leap or if you like to just plod through and do each step one thing at a time. But if I multiply both sides here by x, then the x's will cancel on this side, won't they? Now, how do I get x by itself here? Well, at the moment I've got x times sine 56. So I need to divide by sine 56 to get the x on its own, okay? So dividing this side by sine 56 means I have to also divide this side by sine 56. It's looking a little bit messy now, sorry about that. These sine 56s will cancel out, leaving the x all on its own, and I'll have x equals 10 over sine 56. Okay, now there was nothing wrong with the way that we did that, but it did look a little bit messy. Now, another way to think this through, if I just go back a step to where I wrote my equation, I had this. I want you to think about what happens whenever you have three numbers. This is just three numbers here, and one of them divided by another gives you the other. Well, think of a times tables fact you know really well. Let's take something simple like 3 4s are 12. All right, 3 and 4 are factors of 12, aren't they really? Now, if I start with the 12 and I divide it by one of its factors, what do I get? I get the other factor. Now, if I divided by the 3 instead, what would I have over here instead? I'd have the 4, wouldn't I? So these two numbers 3 and 4, when they're here and here, are really interchangeable. They can just swap places. If I divide by one factor, I get the other factor. Same situation's happening here. It's just harder to recognise because the 10 doesn't look like the big number like the 12 does. One of these is unknown and one of them is really unfamiliar to you. But similarly, if I can divide 10 by x to get all of this, I must be able to divide 10 by all of that to get x. So if you're comfortable doing that, you need to know that you've got to be swapping that entire side with everything that's down here. And of course, if there was something else over in here in the equation, it wouldn't work. But it's a handy little trick to know because it's a quick way to cut to the chase and say x must be 10 over sine 56. Same thing as before, we use our calculator, literally just type in 10 divided by sine 56 equals, and it's given us an answer of 12.0621. Let's round it off just to one decimal place here. Always write how you've rounded it off. And the last step is I check back to the picture and say, would that make sense? If this is 10 metres, and my picture's not perfectly to scale, but would that hypotenuse be 12? Yeah, that seems pretty reasonable, so I probably haven't made a mistake. And we're in metres here, so I need to put metres on. And that's how you find a side using trigonometry.